Today we're going to learn shortcuts. Yes?
There's no homework listed in the packet.
What the? Well, I guess I'll send out an announcement in Blackboard because I don't know what is the top of my head, okay? I'll pick 5 interesting problems. Okay, I didn't say they'd be hard. Okay, the derivative of a constant function. I have 2 ways to explain what this is, okay? First way is a picture because the picture makes the most sense. If you have a function, how did I do that? Okay, if you have a function y equals c or f of x equals c, what does it look like? What's its picture look like?
Just a line?
Is it horizontal or vertical?
Horizontal.
Horizontal. And if it is above or below the x-axis depends on if that is positive or negative, right? Okay. The meaning of the derivative. The derivative is the slope, right, of the tangent line. Okay. If I draw tangent lines here, it's got to go through the point and have the same shape. What are their slopes going to be? 0. So the derivative of a constant is 0, no matter what that constant is, even funny constants, okay? So if you see constant, the derivative is 0. The other way you could do it is you could say, like if we had let f of x equal c, the technical definition is that f prime of x is the limit h goes to 0, f of x plus h minus f of x all over h. You take this c function, h to 0, and you plug x plus h in. Is there any place to plug x plus h in? No. Does that make sense? So it's just c minus c over h. Does that make sense? Which is just limit as h goes to 0. Well, it's 0 divided by h, and this is 0. That's the technical reason, like the proof. But the intuitive idea that a derivative is a slope, this is a horizontal line, its slope is 0, is really good enough. The thing that you've got to be careful about is be careful about constants that don't look like constants. Okay, so if I give you f of x is 5.4, what's the derivative? No trick? 0. Okay, is this a constant or a function?
Constant.
Constant. So g prime of x is equal to 0. It's okay, grab a packet. H of x is natural log of 2. Natural log of 2 is a weird number, right? So h prime of x will equal 0. Other examples of constants? Things like root 2, e to the 7th. Does that make sense? Stuff like that. So if you say, okay, this is a number that this is just its exact thing versus an approximation of it, derivative is 0, no matter how funky it looks. Okay? I'll explain where most of the errors happen when we get to the next rule. So the next rule is called the power rule, and it's pretty easy to figure out what the rule is if you just do a couple examples. So let's find the derivative of these functions using the definition. So the definition, where all this stuff comes from, is take the limit, h goes to 0, f of x plus h minus f of x over h. You've done so many you want to barf. A little bit? Yeah. Just put it in the basket, please. So limit h goes to 0. What's f of x plus h? X plus h squared. What's f of x? Very good. All over h. And then x plus h squared is x squared plus 2xh plus h squared. So we got, 2xh plus h squared over h 2x plus h. So what is that derivative? 2x. Okay. Okay, so there's one. Usually you have to work out more than one to get a pattern or an idea of what a pattern is. The next one's x cubed. So I will give you a hint and tell you what x plus h cubed is because I know how to do it really fast. So for this one, it's the same definition, right? Limit h goes to 0, f of x plus h minus f of x all over h. So that's x plus h cubed minus x cubed over h. And as long as everybody agrees that x plus h cubed, the power doesn't distribute, right? Powers never distribute unless they're 1. And 0, I guess 0 distributes too. 1 and 0, nobody else. So when you cube x plus h, you actually get x cubed plus 3x squared h plus 3x h squared plus h cubed. I can do that super fast because I know a little trick called Pascal's triangle that maybe you have or haven't seen before. But the basic idea is you take x plus h multiplied by itself 3 times, you do massive amounts of distribution, and you combine like terms. That's what happens. The important thing from this example is that you get the pattern that's happening. So now, what happens to the x? What does anything cancel?
The h's, the x cubed.
And then the h's can cancel as well, right? So limit h goes to 0. We'll have 3x squared h plus 3x h squared plus h cubed over h. Or if you had just canceled the x's and the h's at the same time, which is fine, you would have gotten 3x squared plus 3xh plus h squared. Okay. So when you plug in h equals 0, what is that? 3x squared, right? Okay. So tell me if you can see the pattern. So in example A, we had f of x was equal to x squared. F prime of x was 2x. This one we had f of x equal to x cubed. F prime of x is equal to 3x squared. Do you see a pattern there? And could you predict if f of x was x to the 4th, what would the derivative of that be? 4x cubed. See what happened there? That this coefficient ends up dropping down and the power decreases by 1. You see that? You can now use that pattern and don't have to use the definition other than maybe on the final ever again. Okay? Yay, I know. That's why this section's a good one to have on a Friday because your homework will be easy. Okay, great. So if n is a positive integer, then the derivative of x to the n is going to be what? Nx to the n minus 1. Woo! And this part technically says n's a positive integer, but it actually works if n is any number, period. So like even if n is like a power of 1/2, this rule also works. It works for all powers. And we'll talk about that in the next page. Okay. Now a little bit about semantics and writing your work correctly. So when you are taking a derivative, you have to tell me that you've taken a derivative using proper notation. It's like this says f of x equals x to the 9th. You have to say f prime of x equals 9x to the 8th. And how you tell me you've taken a derivative is this little prime thing tells me that you've done that. Some students, when they do this, what they'll say is they'll start with f of x equals x to the 9th, then they'll say equals 9x to the 8th. And that's wrong because what you've said is that your original function equals 9x to the 8th. And that's not true. It's the derivative of your original function equals this thing, right? So to express that properly, you've got to say f prime of x equals blah. To keep track of who's who, right? Because it might be the case that this function is your position, that's your velocity. So it's kind of like just giving them their proper names. Okay, so just stating 9x to the 8th is enough. Say f prime equals, okay? If you have a y, you can say y prime equals, what is that going to be in this case?
99x to the 98.
Exactly. The other notation you could use dy dx equals 99x to the 98th. That's also okay. The first one's less writing, so that's, you know. Okay, so those first two, you're given the equation in terms of f of x equals y equals. This part C, this little thing is like the operation that means take the derivative. So take the derivative of the thing in parentheses, and that equals what? 5t to the fourth. Is it a little bit different than the previous examples? The process isn't different, but the way you can write the answer is a little bit different, right?
So it's totally okay to just put equals.
And that it's okay to put equals because the thing you said, okay, take the derivative of this, and the derivative of this is equal to that. So the fact that that operation is there saying take the derivative means you can just do it like this. Okay. All right, so using the definition of derivatives, you can prove these things. And we kind of already did this, like we did some problems like 1 over x and root x, and that one used a common denominator, second one used a conjugate. So look at this. This is the derivative of x to the, what power is 1 over x? Minus 1. And so if you used your power rule, the minus 1 would pull down. Your power does minus 1 take away another 1. So what's minus 1 minus 1? So does that give you this? Yeah. And so that's just using the fact that the derivative of x to the n is nx to the n minus 1. This is the thing that we pretty much convinced ourselves is true for whole numbers, right? Positive whole numbers. And if I tried to apply that rule to x to the negative first, well, the negative 1 pulls down and goes there, right? And then the exponent decreases by 1. If you decrease negative 1 by 1, it's negative 2. So that rule also works for negative powers. That doesn't really prove it, but that at least gives you a reason to believe me when I say it does. If you were to differentiate root x, what is root x as a power? 1/2. So applying that power rule, it'd be 1/2 x to the 1/2 minus 1. What is 1/2 minus 1? Almost. It's negative 1/2, right? And so then what happens to negative exponents? They have to be punished and sent in the basement. So this becomes 1 over 2x to the 1/2, which is the same as this thing. So that power rule works for x to any power. And we're not going to have like I powers, x to any sort of like rational or actually even irrational power. Like you could technically take the derivative of x to the pi. That'd be pi x to the pi minus 1. I mean, like, you know, specifically, but you know, that's what it would be.
Now that you've showed us this, you're never going to ask us to use the definition again.
You will have to know the definition on your final. So like there'll be like one question where it says do the derivative of blah, knowing the definition. But for the content of this chapter, you won't need to know the derivative, that definition again. Okay? Alrighty. Okay, so differentiate the following functions. So first of all, I'm going to say f of x is equal to x to the negative 5th. And is that okay? I can do equals there because that's still the original function. Okay. And I'm going to take the derivative. So I say f prime. And f prime will equal, you tell me. Yes?
Would it be wrong to say 1 over 5x to the 4th?
I haven't quite, I think that is not correct. Okay? All right, so then you have to first write it as x to a power, and then apply the power rule. So what happens to the negative 5? Drops down. And then the exponent decreases by 1. What is negative 5 minus 1? So negative 5x to the negative 6. And I prefer that you write stuff with no negative exponents. So It's negative 5 over x to the 6th. The exponent is only on the x. Negative 5 is a negative number. There's no negative power on it. Okay. For part B, is everyone okay with the fact that this is x to the 5th to the 1/3? Then what happens to those powers? They multiply, so it's x to the 5 over 3. So y prime is 5/3 x to the 5/3 minus 1, which is 2/3. So 5/3, is that positive 2/3? Yes, it is. You can leave it like that, or you could also say 5/3 cube root x squared. Either one of those is all right, and unless I've specified, the first one is totally fine with me. Okay. So do you like this rule better than the other way? I mean, who didn't, right? It'd be crazy if you didn't. Okay, and if I asked you to find an equation of a tangent line now, how do you find the slope? To find the slope, you use the derivative, right? This is the derivative. You just plug in whatever number I gave you, right? Okay. So we're going to do that. We're going to find equations of tangent lines. And this is just to introduce you to some notation and some vocabulary. There's also something called the normal line. And the normal line is the line that is perpendicular to the tangent line. So if you have two lines, how is the slope of the perpendicular line related to the other line?
It's the negative reciprocal.
So negative reciprocal, so slope is negative reciprocal of tan line slope. So it goes through the same point as the tangent line. It's just you find the tangent line slope and take the negative reciprocal of it to get the normal line's slope. That's all. And probably in classes you've done slopes of perpendicular lines before. My Algebra 1 kids had to do it. Algebra 2 kids did it. My pre-calc kids probably did it. I can't remember if we did it or not.
So the normal line is the perpendicular line?
It's perpendicular to the tangent line. Yep, exactly. Okay, so this thing, before you apply the power rule, you have to write it as x to a single power. Okay, so it has to be x to a power. You can't have a product. There's a rule for products. We're not going to do it until next week. And it's not what you think it is. So could you make this x to 1 power only? Here's my first hint. Does everyone agree with that? Common base, what happens to the exponents? They add. What is 2 plus a half? And I don't want 2 1/2. Or 5 halves. Improper fractions are our best friends. We learn to love them in calculus. Is that okay? Okay. So then the derivative is equal to 5 halves x to the and 5 halves minus 1 is 3 halves. Good. Okay. Now for the tangent line, because we're going to find two lines. We're going to find the tangent line and the normal line. The slope is equal to y prime with what number plugged in? 1. So that will equal, I believe, just 5 halves. Does that make sense? And the reason I plugged in 1 is because I gave you a specific point. I said the point 1, 1. And so tangent lines, their purpose in life is to give you, derivatives tell you slopes of tangent lines. That is what they do.
That's 3 chooses.
Well, it's 1 to the 3 halves, and so since 1 to any power is just 1, it doesn't actually matter. If I would have given you a different number, like say x equals 4, then you would have had to account for that more. But it's those 5 halves times 1 to the 3 halves. 1 to the 3 halves power is just 1. Like you root 1, then you cube 1, you just get 1. So this is 5 halves. Now that you have the slope, how do you get the equation? Y minus.
Y minus y1 equals slope x minus x1.
Mm-hmm. So y minus 1 equals 5 halves x minus 1. I didn't say get it in slope intercept form, so I'm going to be lazy and not. Okay, now the normal line is perpendicular to the tangent line. So what is its slope?
-2/5.
Exactly. And then the equation is y minus 1 equals -2/5 x minus 1. There you go. Okay. Yeah, but the 2 points from that example. Point 1, x2 single power. Point 2 is just what a normal line means, and it's not very complicated, right? Okay. All right, the next thing we have is called the constant multiple. So look at what's written there. So this operation says take the derivative, and then what happened to this constant that was in front of the function? It came and factored out, right? And so the question is okay, can constants factor out of derivatives? I'm going to show you the reason this is true is because of the limit definition, okay? And I'll show you why. So the derivative of the function c f of x is the limit as h goes to 0. Because all the rules we have come from this definition. That's why you have to learn it first. Okay, so it's f of x plus h, which means take this function and plug x plus h in. Does that make sense? So that's going to be c times f of x plus h minus c f of x all over h. And then the reason that a constant can factor out of a derivative is because in this expression, we've got a greatest common factor in our numerator, which is c, and that can factor out of the limit. So c limit h goes to 0, f of x plus h minus f of x over h. And this thing right there is just the derivative of f of x. Or, whatever. But that's the reason the constant can factor out. It comes from using that limit definition and saying, okay, constants can factor out of limits, therefore they factor out of derivatives. You're going to use this rule so much, you're going to kind of even forget that it's a rule. Okay? So here's an example. If I have the derivative of 5x to the 7th, this is the same thing as 5 times the derivative of x to the 7th. Which is then 5 times, what's the derivative of x to the 7th? And then that 5 and 7 can multiply, giving you, exactly. And you don't have to show me 2 steps for that, okay? I just showed 2 steps for how that rule is being applied. But basically the idea is you can kind of ignore the constant, differentiate the function, and then multiply the constant times any other constants you get. Okay, this one is -3 times the derivative of x to the what power? Very good, 5 over 2. So that will be -3 times 5 over 2 x to the, so -15 halves x to the 3 halves. Is that okay? Right. And if you can do this in 1 or 2 steps in your head, you're welcome to do so. Does that make sense? It's good to show me some work like on quizzes and stuff, because then I'll know, like, if you make a mistake, I can, like, know you know more than nothing. But on your written homework and stuff, like, these are really easy questions. Okay. Now, another rule that we can apply is the sum difference rule. So if you differentiate two things added or subtracted, you can just differentiate the first thing plus the second thing. I also want to prove this one is true. So I'll just do it for the sum. So we'll take it, we took f of x plus g of x. It's the limit h goes to 0. The first thing you do when you use the limit definition is you plug x plus h into the thing that's being differentiated. So that's f of x plus h plus g of x plus h. And then minus the original function, which is f of x plus g of x, all over h. And that's the definition you were super, super sick of using, and it sucked real bad, right? Okay, now the next thing I'm going to do is like slightly clever. I'm going to send the negative sign through, and I'm just going to rearrange who's first. I'm going to write this as f of x plus h minus f of x plus g of x plus h minus g of x. All that over h. Does that make sense? I just flip-flopped the order stuff was added. Nothing is wrong there, right? And then I'm going to break it into two fractions. Limit h goes to 0, f of x plus h minus f of x over h plus g of x plus h minus g of x over h. And you kind of use this, so I don't know if you have what I did there, I just unadded a common denominator. And then the last thing is that each of those pieces can be limited separately. And so this first thing is the derivative of f of x. The second thing is the derivative of g of x. What this says, really, and how we're going to use this, is if you have things added together, you can differentiate it one term at a time. First derivative plus second derivative plus, or minus. Minus is the same. You know, minus is like adding a negative, so whatever. Same thing. But the technical way you prove it is you start with the definition, you kind of manipulate a little bit, you say, okay, what pops out is a derivative plus a derivative. The rules for products and quotients are not nearly as easy. So just FYI, be aware that if you see a product or a quotient, you shouldn't know how to do anything with it yet. Okay, so find the derivative of this crazy thing. So y prime will equal, differentiate it one term at a time. What's the derivative of x to the 7th?
7x is 6.
Plus 10 times
3x squared.
Minus 7 times, ooh, what's the derivative of 2x? 2, and then minus 0. So that's 7x to the 6th plus 30x squared minus 14x plus 2. You can totally do that in one step in your homework. Like, I mean, if you can do 10 times 3 in your head right away, no big deal. Yes?
If you're taking the limit of -9, wouldn't it still be -9 since it's a constant?
Think about it in terms of the slope of the tangent line.
Oh.
And it's a horizontal line. And the technical thing, the reason the limit is 0 is if you do the plug in a plus h, it doesn't change because there's nothing to plug in. So it ends up being -9 minus -9 over 0. Okay. All right, find all points on this curve where the tangent line is horizontal. So if the tangent line is horizontal, that means the slope of the tangent line is equal to what? 0. So you have to find where y prime equals 0. That's step 1. So what is y prime?
4x cubed minus 4x plus 1.
Plus 0. Plus 4, because 4 is a constant, its derivative is 0, right? Okay, so then solve 0 equals 4x cubed minus 4x. Does that make sense? Okay, now how do you solve that? You can factor it, yep. There's a greatest common factor of 4x, x squared minus 1, x plus 1, x minus 1. So how many x's will give us a place where the tangent line is horizontal? X equals 0, positive 1, and also, well, negative 1 and then positive 1, right? Is everyone okay with that? All right, one technicality. When it says find the points, that implies it wants the x and y coordinates. Like, that's what that means. And one nice thing about WebAssign is it's going to give you stuff in like ordered pair format, and you'll have to like, no, you got to give ordered pairs. So how would you find the point on the curve given that x is 0? Just plug it in, and it plugs into the original because you're looking for the location, like the how much far up. So if x equals 0, y is equal to 4. So one point is 0, 4. If x equals negative 1, the y is equal to 1 minus 2 plus 4. Yep, 3. So negative 1, 3. And if x equals 1, I think the y is still 3. So 1, 3. So just be careful when it asks for points, it wants ordered pair format. And WebAssign should make that obvious on the written homework, you'll just have to know. That's why you should do WebAssign first, even though it's due after, at least partially first. Okay. Now, since the only rule you know is about stuff raised to powers, if you don't just have singular things raised to powers, you've got to do algebra so that you end up with that in the end. So you don't have any rule for something being squared. And there is a rule for that, we'll learn it later, but most people don't make up the right rule and they try to come up with one on their own. So your job is to somehow use algebra to make this something you can deal with. Does it make sense to everybody that we could at least take this thing and multiply it by itself? And then once we do that, it's something we can actually take derivative of? Okay, so y is equal to 25x to the 4th. I think in the end it's going to be minus 20x squared plus 4. I did skip one step there, but tell me if you think that's okay, because I occasionally math wrong. Well, occasionally arithmetic wrong. We'll say that. Is it clear how I got 20? Okay. Now that's still the original function. Make sure it's labeled as such. Now take the derivative. And its derivative is
25 times 4x cubed minus 20 times 2x equals 0.
So y prime is 100x cubed minus 40x. Does that make sense? Okay. Thus far, you have no rule for quotients, okay? There is a rule for quotients. It's in section, I think it's 3.2, so it's one we're going to do on Monday. But even if you know that rule for quotients, what we're going to do now is actually easier. Okay, so we could make this into everything to 1 power by taking everybody and dividing everybody by x cubed. Does that make sense? And what happens to stuff when you have common bases and exponents? What happens to the exponents? They subtract. So this is x to the 1/2 minus 3 plus 2x to the 1 minus 3 minus 3x to the negative 3, which is x to the negative, thank you, plus 2x to the negative 2, right? Minus 3x to the negative 3. I can almost guarantee you this is going to be on your quiz. FYI, it's like the hardest example you're probably going to see. Something like it. Okay, so f prime of x is negative 5/2 x to the negative how much? Negative 5 halves minus 1.
Negative 7 halves.
Negative 7 halves. Okay, minus 4x to the negative 3. Definitely minus, because the negative 2 pulls down and multiplies by that positive 2. The next one will be plus 9x to the negative 4. Does that make sense? So that's negative 5 over 2x to the 7 halves minus 4 over x cubed plus 9 over x to the 4th. We'll stop there for now. Is everyone okay with how you deal with that? Okay. Actually, I do want to do one more step. The one more step that I want to do, and you can squish it into the next one because the next one's going to be easy, is I'd like to talk about how you get a common denominator there, because it's a little bit tricky, but it's not ridiculous. So the obvious thing that's missing from the second and third parts is they're both missing a 2. Does that make sense? So multiply this by 2, this 2 over 2, 2 over 2, and what is the middle term missing relative to the last term? See what I mean by that? Like the last term is x to the 4th. That one's x cubed. So it's missing an x. Okay. Now the question is what the heck about this x to the 7 halves, right? Like how do I make that match the others? What is 7 over 2 as a decimal? 3.5. So we multiply by x to the 1/2 over x to the 1/2. Do you see how that makes x to the 4th?
Just adds a half.
It adds a half, right? Because you have common base, exponents add. 7 halves plus 1/2 is 4 halves, or 8 halves, which is 4, right? So getting a common denominator says negative 5 root x minus 8x plus 18 over 2x to the 4th.
You want us to do that?
On your written homework, yes. On WebAssign, you can check and see what it asks for. Does that make sense? You're pretty good at getting common denominators when it comes to stuff that has whole number powers. And just see if you can also do it with fractional powers if it happens. Okay. All right, everyone okay with those? Okay. If it was a quiz and I asked you to get a common denominator and you got this right but got that wrong, you're only gonna lose 1 point. Okay, like, I mean, I want you to just try. It's like gonna be like 1 out of 4, 1 out of 5, okay? So. All right, so what is the problem with A? Do you have a rule for when it's a number and a variable to a power?
Root 3t is the same as root 3 times root t.
And that's exactly what you're going to use. You're going to use the fact that this is the same thing as root 3 times root t, and this is the same thing as root 3 over root t. Or in other words, it's the same thing as root 3 t to the 1/2 power plus root 3 t to the negative 1/2 power. And then root 3 is a constant, right? It's a weird constant, but it's a constant.
At the same time, you just factor it out.
You just factor it out, yep. And a root will factor out because it's a multiplication inside of a root. Okay, there is a rule for doing it if you just leave the root, the 3 and the t inside the root, but you don't know yet. It's called the chain rule. It's in section 3.4, and that is Tuesday. Okay? So f prime of x is root 3 times 1/2 t to the negative 1/2 minus root 3, well, plus root 3 times negative 1/2 t to the, what's the new power there? Negative 3/2. So that's root 3 over 2t to the 1/2 minus root 3 over 2t to the 3/2. And let's just get a common denominator because it is probably good practice. So both denominators have 2 2, right? If you add what number to this exponent will it make it 3/2? 1. That means if you multiply by t over t, that makes your denominators the same. So this is root 3t minus root 3 over 2t to the 3/2. Is that okay? Yes.
Just to clarify, it should be f of t.
Yes, it should. It should say f prime of t. The variables should match. Thank you. Habits. Okay. And then part B, which I kind of like scrolled away from. Okay. All right, e to the x plus 2. So is it okay if I say this is the same thing as e to the x times e to the 2 plus 4? Or it's e squared times e to the x plus 4, because then what's the e squared? It's a constant, like the root 3 is a constant, right? That's what I meant. So f prime of x will just be e squared times e to the x plus 0, or it actually is e to the x plus 2. So in that case, you could have not noticed that and still gotten the question right, but that was more luck than anything else. Okay. Alrighty, so the last rule you're going to learn today is what the derivative of the exponential is. So here we go. Favorite function. E to the x is super special. It is its own derivative. It is the only function that has this property. When you take this function's derivative, you get the function itself. And the technical way to prove that is to apply that limit definition. So it's e to the x plus h minus e to the x over h. And this is e to the x, e to the h minus e to the x over h. And I don't have any good way to like go from here that you guys will understand. So this is how you would show that it was true. But what turns out is that this e to the h minus 1 over h, as you plug in numbers that are closer and closer to 0, this piece actually goes to 1. And you could test that yourself by just picking numbers that are close to 0 and plugging them into that expression. So therefore, this goes to e to the x times 1. So this is the only function that has this property. 2 to the x has a little bit different but slightly similar derivative. Okay, so it is its own derivative. The derivative of e to the x is just e to the x. So that's the one function that's special like that. Okay, so at what point on this curve is the tangent line parallel to this line? Okay, well, what is the slope? If we're talking about parallelness, we have to have same slopes, right? What is the slope of that line that's in the box? 5, which you get by saying that's the same thing as 5x plus 2. Slope is equal to 5, right? So the question we're asking is if y equals e to the x, when is y prime equal to which number? Nope, just 5. Because if the tangent line is parallel to this line, it has to have the same slope as this line, and that line's slope is 5. If I'd said perpendicular, you would say, okay, then it'd be negative 1/5. Okay, so when is y prime 5? What is y prime? E to the x. So we want to solve e to the x equal to 5, and can you do that? Yep, x equals ln 5. And it does say point, which means you have to give an ordered pair. So if x is ln 5, y is e to the ln 5, or 5. So the point is ln 5, comma 5. But e to the x's derivative itself is not a trick. Okay, it is actually that easy. Okay. And this question I thought was just kind of fun because it was in your book and it talked about Alaska. So I picked it up because that was kind of cool. So biologists have proposed this cubic function to model the length of an Alaskan rockfish at age A. So L is measured in inches and A is measured in years. And this is only applicable, within the rockfish's lifespan to a certain point when they kind of their growth sort of stagnates, right? Okay. So calculate dLdA at A equals 12 and interpret your answer. So first of all, what are the units of dLdA going to be? What's L measured in?
Inches.
Per
Year.
year. So this is going to describe how quickly your rockfish is growing, lengthwise that is. It isn't describing weight. So rate of growth of rockfish. You think about people, their rates of growth tend to be fastest when they're teenagers, right? People often have growth spurts when they're 15, 16, 14-ish. Okay, so dLdA is the derivative of that L function, which, oh my gosh, okay, somebody calculator because I forgot my notes. So what is this number times 3? Can you just read it to me, Michaela? 0.0.
5 zeros and then
5 zeros and then a 4. I don't think that's right. I think you might have cubed it.
4.
Yeah, 0.0.
0.0465.
That sounds more right. Just take did you cube it?
Yeah.
Yep, that's what I thought happened. Okay, and that should be a to the second, right? And then what is 0.372 times 2? 0.7 something, right?
Times 2 is 1744.
Okay, A, and then plus 3.95. Does that make sense? Okay. And then we want to plug in 12. So dLdA at 12 is 0.0465 times 12 squared minus 0.744a plus 3.95. So at least two of you need to do that so we make sure we have these consistent answers. If you don't mind.
First number will be 6.696.
6.696, okay. Oh, that should be a 12 there, so sorry. That instead of an A, I should say 12. Because you plug in 12 for A.
And second's 8.928.
Okay, and then plus 3.95. Most calculators are smart enough to do that in one go as well. Like if you plug the whole expression in. Except for your iPhones. iPhones suck.
1.718.
1.718. Okay, and that's going to be inches per year. Then just give me a short, complete-ish sentence that tells me what that means. Okay, so when the rockfish is how old? Is 12 years old. It is growing at a rate of 1.718 inches per year. Just in case WebAssign doesn't have an awesome tolerance for rounding errors, I would suggest taking this expression and when you have a calculator, plugging it all in one go. Phones suck for that because the iPhone doesn't do you have to be smart about operations with it. But they might have, I think there is an app that makes a TI-89 or TI-80 whatever out of your iPhone. So you can look at it. I think it's also not expensive. I don't have a phone, but I've heard of this thing.
it's coming from Texas Instruments, I think the app would cost $50.
Somebody might have also made an app that is Texas Instruments-ish and not use the name. Does that make sense? So it may have found a way to circumvent copyright law. But yeah, TI, those things have not gone on price ever. Or textbooks either. Stupid. Okay, last couple questions. The equation of motion of a particle is given by this. So this is like the position equation. Find the velocity and acceleration functions. So that's step one. So how is the velocity function related to this function? It's the derivative. So I'm going to call it v of t is equal to s prime of t, which is the same thing as, tell me. So it's just give me the equation. Just take the derivative really easily.
6t squared
Uh-huh.
minus 30t plus 36.
Yep, there you go. That's v of t. So velocity is the rate of change of the position. How do you find acceleration? Take the derivative of that, which is the same thing as taking the second derivative of the position function, right? Okay. So in this case, what is a of t equal to?
12t minus 30.
Very good. Yep. Okay. All right. Last part of the question says, determine the acceleration when the velocity is 0. So first you must figure out when the velocity is 0. So this means set v of t equal to 0 and solve. So 6t squared minus 30t plus 36 equals 0. And I hope to God there's a greatest common factor, which there is, right? 6 times t squared minus 5t plus 6, right? So how does that factor?
T equals a negative 6 and a positive 1.
I think it's -2 and -3. The reason -6 and +1 won't work is they need to multiply to make +6, and those two multiply to make -6. Sorry, it felt like my bag just buzzed. I don't have a phone, so I don't have my bag buzzing. Okay, so t is equal to 2 and t is equal to 3. So there are two places where the velocity is 0. And you're asked to find the acceleration at these points. So a of 2 is 24 minus 30, or what? -6. And a of 3 is 36 minus 30, right? So a of 3 is equal to 6. I kind of boo-booed and didn't give you units here. Let's pretend that it's S is in meters, T is in seconds, in which case this would be meters per second squared, and this would be meters per second squared. And one conceptual question for the last example. If, because this acceleration is negative, what's happening to the particle?
Slowing down.
It's slowing down. It's decelerating, right? This means it's speeding up, right? Versus like, pushing your gas versus pushing on the brakes. Accelerate, decelerate. Okay. Last question. This is a clever way to do limits without having to do all of the nasty algebra. Okay, so here is the thing. This looks a lot like limit h goes to 0, f of a plus h minus f of a over h, right? Do you buy that? And that, by definition, is the derivative with a specific number plugged in, right? Does that make sense? Okay. So tell me, what is the function that we've plugged stuff into? The function is x to the 5th, okay? But you got the 5th part right. What number was plugged in? 2. Is everyone clear how we found those parts? Do you buy that it looks like a derivative, right? You buy that it looks a lot like this, right? You agree with that? And this thing by definition is a derivative with at a specific number, okay? So another way to find this limit, instead of doing all of the algebra and fifth powering that business, which is going to get really disgusting really quickly, you can take the derivative of this and you can plug 2 in. So f prime of x is 5x to the 4th, right? So f prime of 2 is 5 times 2 to the 4th, which is 5 times 16, or that's 80. And this limit equals that. If you want to verify it for yourself, you could take 2 plus h to the 5th and multiply it all out, and then get that. You'll get that the limit is 80, but it's a shortcut. So the things you have to recognize, you have to say, oh, okay, I have a function that's being differentiated. What is your function? What is the point? And that limit is the derivative at that point. This is the trickiest thing to spot. So, I mean, there'll be a couple of questions like this, and just gotta piece your way through them. Okay. Part B is the same thing, but it is that other definition that said f prime of a was the limit as x goes to a, f of x minus f of a. That's the one that we did first, but didn't really use much. Does that ring a bell? So what is the function in example B? X to the 99th power. And then what is the a value? 1. And so this limit will equal f prime of 1, and f prime of x is 99x to the 98th. So f prime of 1 is 99. So that's the value of the limit. It's 99. Okay, then just the last thing. Notice with this last one, that's your a. You see that relationship? And the function f of x is this function. Whereas this one second, I'll answer your question in a moment. This, the number is your a. And the thing you're doing to it, that ends up being your f function. So, and you had a question, I didn't want to ignore you.
No, so for A, like, I can see where you got, like, I guess x to negative 5. Did you just put x in for h? So where in the equation it says 2 plus h, h to the 5th, you just replaced that h with x, essentially is what you did?
Yes, effectively, yes.
Okay.
Yep.
All right.
Yep. So the kicker is that these are derivatives, and instead of doing the limit, you can say, oh, it's a derivative. It's this function at this point. So those are tricky. You can go, if you really want to, you can go back and look at all the limits you did before and say most of them are actually derivatives. So, okay, that is all for today. And I am going to